Partial fraction decomposition was this thing where we took a rational function and we broke it up into the sum of smaller rational functions, where each smaller rational function was smaller in the sense that its denominator was of a lesser degree than the original rational function. We did this by taking our rational functions and factoring the bottom. Ooh, on the spot, what does this factor do? This factors to x plus 1, 2x plus 5, despite the fact that I had that written there already. I did that on the spot. That was pretty good. Good job, Mr. Novick. And we would take this rational function and we would break it up into smaller rational functions. Like this. That's the most basic rational function. And this video is just going to be about setting these up. Setting up the a over a fraction, b over a fraction, that stuff. I'll do another video on how to actually figure out what a is or what b is. But for now, I just know there are going to be some numbers, a and b, that will make this true. So let's practice setting it up. Look at how it gets harder. If I have my denominator all factored and they're all linear terms, I just need to include one fraction for each term on the bottom. This is how I would set up this partial fractions decomposition. I would just set it up simple as that. One way that it gets more challenging is if I have some of my terms get squared or cubed. In that case, I have to include them twice. One time I have to include it in its normal form, and another time I have to include it in its higher degree term. The x minus 3 is just the first power, so it just shows up once. The 5x plus 1 is to the third power, oh goodness. So it's going to show up, I'll write it down here, once in its normal term, once it's going to show up squared, once it's going to show up cubed. Now what goes on top is still just a, b, c, all these different numbers. If you're thinking to yourself, I kind of remember sometimes there being other things on top. Yes, sometimes there are other things on top. But when it's just linear things in my parentheses, just x plus a number, things that look like lines if I were to graph them inside the parentheses, that's when I just have to put a or b or c on top. I don't put any x's on top. Because it's linear on bottom, the degree on top is going to be smaller. Smaller than linear means it's going to be constants on top. So, where it's not constants on top is if I have these quadratics in the bottom that don't factor. This is a quadratic that does not factor over the real numbers. This is a quadratic that does not factor over the real numbers. If I do b squared minus 4ac, I get a negative number, so I know this would have imaginary zeros. So I know it does not factor over the real numbers. I'll set this up by saying, well, there's only one of these, so it's just going to show up once. It's going to show up as x squared plus 5. And there's only one of the others, so it's going to show up as x squared minus 2x plus 9. On top is going to be something of 1 degree smaller. The bottom of this is quadratic, so on top it's going to be linear. The bottom has a degree 2, so the top has a degree of 1. This, the bottom has a degree 2, so the top is going to have a degree of 1. If I mix these two, this is somewhere where people often make mistakes. Is they see this 2 and they think quadratic, they see this 2 and they think quadratic, and they don't get that there's a distinction here. This is a quadratic that cannot factor. This is linear, it just happens to be the second power. The linear term, it's the second power, so it's going to show up twice. Once it's going to show up as x plus 1, the other time it's going to show up as x plus 1 squared. That x squared plus 4, so the first power, it's only going to show up once. X plus 1 is linear, so I have an a on top. X plus 1 is linear, so I have a b on top. X squared plus 4 is quadratic, so I have a cx plus d on top. Even though this is a quadratic thing, it's here because it's the square of a linear thing, so it's just a b on top. This is not just the square of a linear thing, it's quadratic, so I do a linear on top. One spot where people often make mistakes is they see x squared and they freak out, they don't know what to do about it, so let's make sure that doesn't happen. X squared is the same as x squared. It's the square of this linear thing, it's x. It's squared of a linear, so it's going to show up twice. It's going to have x here and x squared here. X plus 3 only shows up once, so I'm going to have, x minus 3 only shows up once, so I'm going to have it here. X squared minus x plus 6 only shows up once, so I'll only have one fraction in my partial fraction decomposition for it. X is a linear thing, so I'm just going to put a constant. X squared is quadratic, but it's the square of a linear thing. It's the square of this linear thing. So I'm just going to put a constant. Constant is one lower degree than linear. X minus 3 is a linear, so I'm going to put a constant. X squared minus x plus 6 is this quadratic that does not factor. So I'm going to put a linear thing on top. It does look like it factors, right? Because 2 minus 3 is negative 1, and 2 times 3 is 6, but the negative and positives don't line up quite right. That's how I'd factor this. Do partial fractions decomposition for this. The takeaway here is not just is this a good practice one because it's got some quadratics that don't factor and some linears that are squared. It's that when you have an x is this linear thing. The x squared, originally there weren't parentheses there. When you see x squared, yes, you're like, oh, that's quadratic and doesn't factor, but it does factor. It's x times x. It's x squared. Okay, I've belabored that point enough. Let's just try this one more. Certainly you should be throughout this whole video, but even especially at this point, pause the video. Try to write how you would set this up. Then hit play, see if you're right. X squared plus 5 is to the second power, so it is going to appear in two different terms. The first time it will appear as x squared plus 5. The second time it will appear as x squared plus 5 squared. X minus 6 is only to the first power. It's going to appear once. X plus 2 squared is going to appear twice. First it will appear as x plus 2. Then it will appear as x plus 2 squared. I'm saying first then as if the order actually matters, but order is commutative. You could put the x plus 2 squared first and then the x plus 2, of course. X squared plus 5 is quadratic. It's a quadratic that does not factor further. It's not made up of linear, it's quadratic. It's going to have an ax plus b. X squared plus 5 squared is just the square of a quadratic. I'm just going to have cx plus d. X minus 6 is linear, so I put a constant. X plus 2 is linear, so I put a constant. X plus 2 squared is square of a linear. It came from a linear, so I just put a constant. That is how I would set this up. To actually solve for these, I'm going to have to clear my denominators and do kind of interesting things that I'll do in a different video.